Okay, so today we're going to do an investigation of how we measure the amount of osmosis that's going on in a potato chip. So the first bit, what equipment do we need? Well, you've got some salt solution. You can do this with sugar, but we're going to do it with salt mainly because salt isn't sticky, and if you do it with sugar solution, you end up with sticky tables afterwards. We've got our distilled water. Take a small pot of distilled water from the container over there. You need a cutting tile. You need a pen, 5 test tubes, and unfortunately you're going to need 2 test tube racks because they're small test tube racks. A knife, okay, a core borer, which is going to cut at particular dimensions, okay, and there's only 5 of those, so you're going to have to use them and then pass them on. And then our potato. The first thing, and I'll do this, is you're going to take the potato and we're going to just cut the potato roughly into a wedge that's going to be just over 2 centimeters. So I'm just going to roughly do that. Now, this potato is enough for 2 or 3 groups. Okay, so don't be wasteful because you can actually use this for 2 or 3 groups. So take your potato. Now, as you can see from the table we've got on the board, we've got different things we're measuring. So what's going to be the independent variable in this experiment? So can you tell me what's the independent variable in the experiment?
Like the amount of salt solution.
I was trying to use the word amount.
Okay, the concentration.
Good, because amount can mean volume or concentration. So we're using the concentration of salt solution, okay, of sodium chloride solution. What's the variable that we are going to be measuring? Okay, what's the variable we're going to be measuring? Yeah?
The change in mass.
We're going to be measuring the change in mass. And so to measure a change in mass, we need to know what 2 things? The mass at the...
The mass at the initial mass and the final.
Good, the initial mass and the final mass. So we're going to measure the change in mass. Okay, and actually, in fact, we're going to change that also to percentage change in mass, and I'll explain why in a minute. There are quite a few controlled variables. Okay, what are going to be the controlled variables in the experiment? What things are we going to keep constant? Yep. We're going to try and keep that constant. We can't really keep it constant because we're that precise. But we are going to try and keep not so much the weight, or the mass I should say, but the dimensions of the potato. How do you think we're going to keep the dimensions the same? Yep. So we're going to cut them to be 2 centimeters long. How do we control the width of the potato chips? What have we got here on the tile? It's a square. Core borer. It's a circle, so it's always going to do what? It's always going to cut them to be to the same diameter cylinder. So it's going to create cylinders, is the technical word there, and the cylinders are always going to be of the same diameter, and you're going to cut them to the same length. You're going to need 5 of them. Think of another controlled variable, something else you're going to keep constant.
You're going to keep the same potato.
We're going to use the same variety of potato. That could be a bit important. And the same. You're all going to take your chips from the same potato. Anything else?
Test tube potato.
So we're all going to come and collect our results at break. So what's going to be the same for the time that they're in there? It's going to be the time, isn't it? Okay. So the time's going to be the same. And also, we're assuming what's constant in
The oxygen.
Well, not the air. What could speed up?
Catalyst.
No. Temperature. So temperature could speed up because the molecules move at different speeds, at different temperatures. So let's get on with the practical. What we're going to do first of all then is going to cut. I'm not going to cut all 5, but take your core borer. Start at the edge. Do not get any potato skin on it though. Do not get any potato skin because the skin is impermeable to water. So start at the edge. Cut it onto a tile because cutting onto your hand is not safe. Take the borer out, and then using the end of these paintbrushes, rather than these, because these will just cut it further, just push out the tube. Okay? Now, if it's not exactly right, you can always cut them again. Let's just do a couple. Again, do them really close to each other. Don't waste potatoes. You can get about 3 groups out of this.
That's really satisfying.
Now, once you've got all 5, take a ruler, place them next to the ruler, Okay. Take them next to the ruler and then just cut them all to be 2 centimetres long. And it's not extremely precise, but that way they're all going to be roughly the same length. Once you've cut all 5 of them, take a paper towel, and this is a great technique for doing this because you won't mess them up. Take a paper towel, put them all on the paper towel, go to the scales, one by one, place each one on the on the scale, weigh it, find the mass, write the mass on the paper towel next to the potato chip. Okay? And that way you will know which mass of potato chip is going into each tube. Now that's one person's job. So one person's job will do that. The other person's job is to prepare the solutions. So in the first tube it's going to be easy. We're going to do 20 millilitres. That, by the way, is another controlled variable, isn't it? The same volume of liquid each time. So we're going to have 20 mils of water in the first one. In the second one, we're going to have 5 mils of salt solution and 15 mils of water. And you're going to need a measuring cylinder. And to save time, you can just mix it in the same measuring cylinder. You can just take your 5 millilitres of salt, use a pipette to help measure it out. And you'll know you've done it right, because if all these tubes are the same, they should all get to the same level. Groups that have done it wrong, have not followed the instructions, will end up with tubes of all different heights. Okay, so I'm going to top that up to 20. I'm only going to do one. So this one is going to be our 25% salt solution. Okay, put that in and make sure you've labelled the tubes. So use your pen to label them 0, 25, 50, 75 and 100. Okay, and you can put an initial on them as well. Once you've got them all done, you're ready to start the experiment. Make sure you've written down the starting masses in the table. Okay, and then, it doesn't have to be simultaneous, really, it's not that precise, but place all of the potato chips into the solutions. Okay, remember, this is a common mistake, do not place the potato chips into the solutions before you've measured their initial mass. A lot of people get carried away and start putting the potato chips in there and realise they haven't measured the mass and have to take them out again. So put the potato chips into the solution, and then we're going to leave it for about an hour. Okay, it's about the amount of time we've got, and then you'll come back, and then all the person has to do when they come back is they have to take them out one at a time. Just put your hand out, pour the solution through your hand, okay, so you catch the chip, and then put the chip onto a paper towel with a number next to it, say which number it is, 1, 2, 3, 4, 5, okay, 0, 25, 50, 75 or 100. Then take it over to the scale, all of them together, and then just weigh them one after the other. Before you weigh them, you've got to do something before you weigh them. What do you think one problem is? Because they've been in the liquid, what do you think the problem might be? Yeah, guys, they might be wet, so you need to just roll them a bit. Don't squish them, but just roll them lightly on the paper towel to remove the excess water on the surface. Okay? And once you've done that, you'll hopefully then notice a difference. You can work out the change in mass, okay, and then you can work out percentage change in mass. How do you think we work out percentage change in mass? Right, go. Close one. So someone else want to have a go? Go, and it's change in mass divided by what? Change in mass divided by original mass. Okay, or starting mass, then times by 100. Why do you think we do percentage change in mass? Yeah? Yeah, because they all might be slightly different starting masses, so percentage change in mass is a bit more comparable. Okay? Some of the figures will be negative, so you will get some negative changes in mass. Okay, so if the mass is lower than it was to start off with, you're going to get a negative number. and then you're going to get a negative percentage change. So do watch for that when you're doing your calculation, and we'll look again at that next lesson. So just make sure you get your table filled out today, and we'll be doing the graph plotting next lesson.